Welcome. In this video, I'm going to go over the paper 1 questions, or the multiple choice that showed up in your topic 1 test. And I'm going to try and keep in mind how you should be able to answer these without a calculator or your data booklet. You do, however, have a periodic table. So number 1, what is the mass in grams of 1 molecule of ethane? Well, what I know from the formula C2H6 is that I have 2 carbon at approximately 12 grams each and 6 hydrogen at 1 gram each. So I've got a molar mass of about 30 grams per mole. I also know, or you should know, that Avogadro's constant says 1 mole contains 6.02 times 10 to the 23rd atoms. So if I divide 30 by 60, I'm going to get 5, which quickly narrows down my choices. And the 10 to the 23rd being on the bottom means that if I bring it up to the top, it'd be 10 to the minus 23rd. So B seems like a reasonable answer, 5 times 10 to the minus 23rd. Number 2, which sample has the greatest mass? So I need to get to molar amounts if I'm not there already. So 6.0 times 10 to the 25th molecules. To get that to moles, I divide by Avogadro's number, 6 times 10 to the 23rd. So 6 divided by 6 is going to be 1. 10 to the 25th divided by 10 to the 23rd is going to be 10 to the 2nd. So I'm talking 100 moles of hydrogen. Well, 100 moles times 2 grams per mole for H2, we're talking about 200 grams here. B, that's easy. It's already 5 moles of neon. So I look neon up and see that neon has a molar mass of about 20 grams. So we're talking about 100 grams for the neon. 1.2 times 10 to the 24th atoms of silver. I would like to think of that as 12 times 10 to the 23rd, because then when I divide by 6 times 10 to the 23rd, I realize it's 2 moles of silver at 108 grams each, so 216 grams of silver. And then 1.7 times 10 to the 2nd grams. This one's the easiest one. I just changed my scientific notation to 170 grams. And C, 216, would be the greatest mass. Question number 3, which compound has the empirical formula with the largest mass? Well, I need to reduce each of these or simplify to their empirical formula. So I have C1H3. Number 6 is a combined gas law. So we're looking at P1 times V1 over T1 equals P2 times V2 times T2. I know it's the combined law rather than the ideal because it's telling me the change in volume from 3 to 6. The volume of an ideal gas at 27 degrees is increased from 3 to 6. At what temperature will it have its original pressure? So what it's telling me is P1 and P2 are going to be the same. So I can eliminate them, or I can make up a value if that would make you feel better, but P1 is going to equal P2. So then the volume is 3 decimeters, becoming 6 decimeters. T2 is what I'm trying to find. T1 is 27 degrees, but I have to change that. I have to add that to 273 and change it to 300 Kelvin. So I go ahead and get my 300 Kelvin. So I end up with 300 times 6 over 3 being equal to T2. So 100 times 6, that's 600, but that's Kelvin, and they specifically said in degrees Celsius. So I have to minus the 273, undo the Kelvin, and that yields the 327. Number 7, 5 decimeters cubed of carbon monoxide and 2 decimeters cubed, and remember when you see decimeters cubed, think liters because we're Americans, at the same temperature and pressure are mixed together, so under the same conditions, assuming complete reaction, so they're both limiting reactants, so all the CO and all the O2 combine to give you CO2. What's the maximum volume of carbon dioxide? Well, my 5CO would produce 2 CO2 per 2 CO. So I could get 5 liters from the CO. O2, on the other hand, I start with 2 moles of O2, but I can make 2 CO2 per 1 mole of O2. So this is going to double to 4 CO2 that I can make. But still, 4 is less than 5, so B, I'm going to be limited to 4 decimeters cubed. And the reason I could do this without changing it to moles is because they're all gases. Now, they really should have had a G here, but it does say it up here that the CO2 is a gas as well. Number 8, 8.5 grams of NH3 are dissolved in water to prepare a 0.5 centimeter cube solution. So since I'm talking solutions, I'm going to think 0.500 liters instead. Which statements are correct? NH3 is the solute and H2O is the solution. No, H2O is the solvent, and together they make up the solution. So one's out of there, which means you've just eliminated all but one choice. So if you're confident about that, this is a really easy one. But we'll go ahead and check the others. The concentration of the solution is 17 grams per decimeter cubed. Well, if it's 8.5 grams in half a liter, yeah, it should be 17 grams in 1 liter. So 2 appears to be true. And the concentration is 1 mole per decimeter cubed. Well, 8.5 grams, if I look at the molar mass for NH3, 14 plus the 3 hydrogen is 17. So I've got 0.5 moles in 0.5 liters. Yes, that's also true. So I can confidently answer that C, 2 and 3 only are correct. Number 9, what is the concentration of NaCl in moles per decimeter cubed when 10 cc's of 0.2 molar NaCl is added to 30 cc's of 0.6 molar NaCl? So this is where you use C equals N over V. The volume's easy. 10 centimeters and 30 centimeters. I'm going to have a new volume, new total volume of 40 centimeters cubed, or 0.040 liters. The moles is the tricky part. I can't just average these. I can't do C1 times V1 equals C2 times V2 because I'm not diluting my stock solution to get a new one. I'm adding 2 solutions. So I have to find out how many moles I had. 0.010 liters times 0.200 liters means I started with 0.002 moles in my first solution. My second solution at 0.03, I guess I have another 0 there if I'm counting sig figs, 0.0330 times 0.600 means this one was 0.018 moles. So my total moles from the 2 solutions I'm combining is 0.020 moles, and I'm combining them in 0.040 liters, and when I divide that, that gives me a concentration of 0.5. Again, the math isn't that challenging even without a calculator. Number 10, what volume in cc's of 0.2 molar HCl, so HCl, I want to know the volume, and it's 0.200 molar, is required to neutralize BaOH2, and it's 0.025 cc's, and actually they want the volume in cc's, so I could just leave this as cc's, or I could convert it to liters and convert back. Either way, it's going to work fine. I'll convert it, 0.025 liters, 0.200. And this is one that, because they're the same concentration, what you really have to look at is how many H's do you get per OH, and it's, I need 2 HCl per BaOH2, and I could finish writing the equation because I'm going to form 2H2O, and I'm going to form BaCl2. Or I could see here that barium hydroxide gives up 2 OHs, which means I need 2 HCl's to take those 2 OHs. So what that's letting me know is this is a 2-to-1 ratio. So I'm going to need twice as many moles, which means I'm going to need twice the volume. So that would be the short way to it. Otherwise, go ahead and calculate your amounts here. 0.025 times 0.200 means I'm talking 0.005 moles. I would need twice as many over here, so 0.010 moles. And if I have 0.010 moles, and I divide by 0.2 moles per liter, that will still give me my 0.05 or 50 centimeters cubed.